Valence electrons does it have? 1. So how many, is it going to lose that 1 or is it going to gain it 7? What do you say? Is it going to lose 1 electron or is it going to gain 7 electrons? It's going to lose 1. That's way easier. So what's your charge? No, don't. You're losing negatives. So you're a positive 1. Okay, group 1 gets a positive 1 charge. What is oxygen? What group is oxygen in?
Like 6.
Group 6. Okay, how many valence electrons does group 6 have? 6. Is it easier for it to lose 6 or gain 2? So what's its charge? 2 negative, right? So 2. So you lost 2. So the crisscross rule. This is it. This is all it is. You take the charge. You take the number of the charge and you're going to put it down here as a subscript on the next element. You take the number of that charge and you put it as a subscript here. So there are going to be 2 numbers there. It's called the crisscross rule. So it's now sodium. What number goes down there? Just the number, not the charge, not the sign. Just 2. And then O1. There you go. That's name. Its name is sodium oxide. That's what it is. It's how they combine to neutralize each other. That's what it is. Yes, it is very easy. But you have to know the charges. That's the hard part, right?
Yeah.
Okay, another question on reading guide 9 right now. Yay, nay? We are going to go over more of these, like, kind of more in depth during class, yeah. What do you know about compounds ending in ate or ite? So we're going to see, okay, hold on. Before I move on, what did I just call that?
Sodium oxide.
Oxide, right? You heard me say "ide" ending. So that's what number 10 is. So it's called a binary compound. What does binary mean? 2. It's sodium and oxygen. 2 things together. But what if I had how many things are together there? How many different elements? Sodium, carbon, and oxygen, right? That means it's a ternary compound, ternary meaning 3 or more. So it's just a bigger compound. So that's not going to end in "ide." Its name is sodium carbonate. Okay, so the "ate" ending indicates it's something bigger than 2 elements. The "ide" ending indicates that it's just 2 elements put together but in a certain way. So "ides" are simple, "ates" and "ites, which is the other question that, or other ending on question 11. That's what that refers to. Something a little bit bigger. More elements involved. Okay, so reading guide 9 probably sounds like you're learning a foreign language. Okay, chemistry, probably so far you're like, oh yeah, I totally knew this was a foreign language because this is something I'm not familiar with. But chemistry is we have to speak the same language. And to speak the same language, we have to know the rules to how to say certain things. How do you change it if this is present? How do you say it? How do you write it? How do you go backwards and read it and write it in a formula? So we're going to learn a lot about that today. But I have a couple things that I think that you will really just catch on to really quickly. So I want to have a look at those first. And everybody, people in the front, you guys have a big piece of paper. Pass that back for the people. And everybody else, pass up your reading guides. So it's just going 2 ways here. If you have reading guide 7, pass it up anyway, because I want to know that you did it. If you did the wrong reading guide, pass it up anyway. I'll give it back to you. All right, so you're passing up reading guides, you're passing back the paper. We'll use the big paper shortly. I have quiet A, but you can come in. Yeah, totally.
Are you allowed to
I have to respect people that I will talk about it. Okay, guys, stay focused with me. Stay focused with me. All right, thank you for the reading guides. Preach, preach. All right, so quickly explain these to me in like 2 words, okay? Valence electrons means outer shell. And we just went through it. 1 through 8, groups 1 through 8, what are their valence electrons? Their number of group, right? 1 through 8. So the valence electrons of the noble gases is what? 8 electrons, right? So that's what the octet rule refers to. Octet means 8, so it means you want 8 electrons, like the electron configuration of that of a noble gas. What about cation and anion? Which one's positive? The cations, and the anions are? What commonly is going to form a cation? What type of element? Metal or non-metal? Metal. You remember the metals? So if you draw the little tower, where are the metals at? Basically anything past the stairwell that way, right? That's the metalloid line. So everything over here is metal. Everything in this little corner up here is non-metal. So most of the stuff on the periodic table is metal. Okay, and let's hit the other part of review. Some of this is a lot of review at first, okay? So I'm gonna save these. These are what was on your number 13 or 14 on your reading guide. Remember defining these? Those of you who did it, I'll walk through that later, because that's something that's just too much to write right now. Okay, this is something I want you to write on a separate sheet of paper. And then we're actually going to, I think that organizing the rest of the information past this in a foldable form will help. So that's what the big paper's for, and I'll show you how to fold it momentarily. Right now, we're going to start talking about nomenclature. And I'm going to cut the lights a little bit because my board is fading. It's outside. I think it's easier. Is that easier to see? If you feel like you are for some reason going to doze off, please stand at the last station. Stand. Okay, so these are kind of like the alphabet, the words, and then the language of chemistry. And the word for the language of chemistry, or how to name things in chemistry, is called nomenclature. So I'm going to say nomenclature a lot. You're like, what is that? It's like this word stoichiometry. Stoichiometry just means chemistry, math. Nomenclature just means the language of chemistry. So we have the alphabet, aka the symbols that we use. So those are going to be just whatever we found on the PTOE. It's just going to be simply the periodic table of elements that has all the symbols that we would ever need. But if you had to put associate another noun with the symbol, you would call it an atom. Like I have an atom of sodium, or an atom of chlorine. Okay, so it's describing the symbol. So that's what we call atoms. If we have multiple symbols together, and they're bound together through chemical bonds, so I'm going to say chemically bonded, where they have different names just as in their noun. So there are two words here, molecules and formula units. The word molecule refers to anything that is covalently bonded, and anything that is ionically bound or has an ionic bond, that will be called a formula unit. I tend to abbreviate that FU. Okay, you'll see that a lot. Nobody should take any offense to that. Okay, so sodium chloride, the first one, is that ionic or covalent based off your prior knowledge already? What do you guys know about ionic compounds? What do they consist of? I'm going to point it out to you. This is a metal. Sodium is a metal. Chlorine is a non-metal. So that's telling you right now, metal and non-metal is ionically bound. That is going to be called a formula unit of sodium chloride. And then this one right here, who knows what that's called? Show me the whole thing. Whole thing. Carbon dioxide, right? So carbon dioxide is non-metal, so that's going to be covalently bound together. So this is a formula unit of sodium chloride and a molecule of carbon dioxide. So the molecule is CO2 in this case, and the sodium chloride is the formula unit. So it's just, we just have different words. Because like I could just say everything, everything here is a compound, yeah, but it's an ionic compound or covalent compound. Just like everybody here are people, but we have boys and we have girls. It's just further distinguishing what kind of compounds they are. And then the last part is when we actually start to put things together and we make them react, and not just a chemical equation. But in this case, I want you to describe it the way that I've just kind of described it here. So what is the 2 indicating? This recipe calls for 2 what? Two what of sodiums? 2 atoms of sodium. And then what is this? This is Cl2. This is like Cl bonded with Cl. So 2 atoms of sodium. Two nonmetals together. What do we call those? Molecule, right. 1 molecule of Cl2. When they come together, they make a what of sodium chloride? Or 2 what? What kind of compound is this one? See, it's metal, non-metal. Formula unit. Yes, thank you, whoever said it. So 2 formula units of sodium chloride. So that is like a code, right? You're like, okay, 2 atoms of sodium plus 1 molecule of chlorine gas, yields 2 formula units of sodium chloride. So it is a language, right? But you have to read between the lines to get the words out. And we will use that. We'll practice a lot, no worries. But I want to get you introduced to the vocab. All right, give me another second there. If you are ready, you can start folding your paper into 3, just a trifold, make a trifold board out of it, basically. Like a brochure, yeah. For all those people who are, you're trying to entice them to come to chemistry to learn, and it's flashy brochure for them. Let me tell you about ionic bonds. I do have some labels I would like for you to use. I'm going to leave this up here for just a second more for the writing. If anybody wants, do you have a colorful thing to write with that pencil? Can you use some colorful? We have some markers or crayons. It's not considered work, but it's kind of boring. But we do that. You guys pass out some. Do you want any special colors? First come, first serve. Yeah, you can pass that. I'm just handing out a couple. Yeah. Just refold. No, look, Caitlin. Okay. I'll take the armoire. All right, so take me with me. If you can't fold it, then we will go back to that another time. But basically, we're going to have 3 big sections. In front and back of this section will be indicated or will be related to this topic. So our first section is going to be about ionic stuff. We're talking about ionic for the first maybe 20 minutes now. And I'm going to kind of show you what I've done here. Now I haven't filled mine all out, but I've got it organized for you. Then the next thing we're going to talk about is covalent bonds. And then tomorrow we're going to talk about metallic bonds. So that space in the middle is going to be empty for a while. So on the outside flaps. So my first flap is ionic. I'm actually going to be, I can't use a 3D motion here, so I'm just telling you what's on the outside. Properties are on the outside flaps. So I'm going to put properties, and then I'm going to leave some space at the bottom for something else later. And on the inside of the flap for ionic bonds, I'm going to talk about the nomenclature notes. I'm going to talk about the nomenclature rules. And then on the outside of the covalent tab is properties and something else later. And on the inside is nomenclature. This is going to be very organized for you because some of you guys need some help with organizing your notes. Some of you guys do beautiful notes and have really good ways to study. Some of us need a little help. So I'm giving you suggestions. So I'll tell you exactly what you're going to be putting on the outside. It's going to just say ionic and then properties. And we're going to list a couple here. That's on the outside flap. The right door, left door, my bad, left door.
On the inside nomenclature?
Yep, nomenclature, right. I'm going to do it step by step, so no worries. Okay. I will tell you the headings as we go. All you really need is the front flap right now. I mean the left-hand flap for you says Ionic, and it says properties at the top. We're going to list down some properties, okay? So the properties that we kind of just talked about for ionic bonds or ionic compounds is that they contain, in this case, this is exactly as it's written, a metal and a non-metal. So just put contains M plus M or plus MM, metal plus non-metal. That's how you know it's ionic. So if it has a metal in it, you better believe it's ionic. Off the bat, you should be able to identify something's ionic or not. Method of bond formation. So bondings are kind of the second half of this unit, but I'm going to give you just a preview because you already know this. How do ionic bonds form? Electrons are donated or given away. Okay? So if you lose an electron, you become a cation. If you gain an electron, you become an anion. So that's kind of the premise of ionic bonds. When electrons are donated or lost, one of them has lost it, so it's the cation. The other one has gained it, so it's the anion. So that's how we make the ions, and then they love each other, they're attracted to each other, so they form a bond. With me so far? Can I repeat anything? Yeah? So how are the bonds formed in ionic bonds? The very first step is somebody's got to get rid of an electron. So if something is one of the elements is donating an electron, itself has lost an electron, therefore it's a cation. The other thing that gained the electron is negatively charged, so it's the anion. And then they form an attraction between each other. You don't have to. I'm just giving you some pictures and stuff to fit in there too. Okay, so structure. What does an ionic bond look like? It looks like a crystal. This is a crystalline structure. Looks kind of crazy, right? So just put crystalline structure. And you can see it's got layers and layers and layers. But the green and gray in this one, there's sodium and chlorine. They alternate because two sodiums don't want to be near each other because they're both positively charged, and two chlorines don't want to be near each other because they're both negatively charged. So it's a crystalline structure. If I can make that neater for you, I will. Okay. Tell me what state of matter this is. Solid. Okay, so ionic things are generally solid at room temperature. Solid at RT. Room temperature is RT. Okay, so what do you think in your head is a prime example of an ionic compound? I've said it probably 3 times now. Sodium chloride, and that's also known as table salt, yeah? What you put on your french fries. I know it's iodized and stuff sometimes because we need iodine in our diet, but it's just what you normally think of as salt, table salt. That is an ionic solid. And it's solid at room temperature. It looks like a crystal if you got really close to it. You don't know that, but now you do. It's got metal and non-metal. So I'm actually going to say melting points with examples. You don't have to write the examples. Just say high MP, high melting point. Okay, it probably, I think, I don't have the value memorized. It's like 600 or 6,000. I know there's a big difference between those two numbers. Lies. It's 800 degrees C, okay? So like sodium chloride melts at 800 degrees C. That's crazy high. So that's why I just say high melting point, because you don't have to know the specific ones. Okay, fun fact, you put sodium chloride in water. What happens? It dissolves. So the word for the word for dissolving is also ionizing. Okay, so ionizing means it makes, guess what? Ions, right? So, do you think that would be a conductive solution or a non-conductive solution? Conducting to electricity or not? Yeah, totally. That's why you don't go stand in the ocean in a lightning storm, because you're going to get electrocuted. So, solubility in water makes its electroconductivity, yes, it is electrically conductive in aqueous, aqueous state. Okay? So that means that only whenever it is in its dissolved form is an ionic solid, is an ionic something going to be electrically conductive. If I just have this solid, this hard solid, the electrons, I'm going to add to my little crystalline structure here, the electrons are stuck. Okay? They can't move, they're stuck. So they can't move and conduct electricity either. So in the solid state, it's not electrically conductive. In the aqueous state, meaning soluble in water, it is conductive. That's just because the ions are kind of free to move around, float to and from. Okay, that's all we're doing there. You got properties? Let's do a quick recap. You have these. So, we have high melting points. Okay. Oh, let me start up here. Well, we already did that. Formulants, we did that. The reason they have high melting points, this is my cheat sheet to remember to study these things, is just because they have very, very strong bonds. So you can add that to why you have a high melting point. Just because their bonds are so strong. Because they're so attractive to each other, okay? The two ions are really, really highly attractive. And we just said they're electrolytic. What do you think what word that we just talked about meant electrolytic? Electrically conductive. And that's what that I just told you is in their not solid state, but in their other states. Solid room temperature, crystalline structure, soluble in water, donate electrons in order to make the bond. I think we're pretty good here. The whole thing with the crystalline structure being brittle, who's ever seen one of those huge salt blocks like for like deer licks and stuff? Deer licks? Nobody grew up in North Carolina? Okay, so we're in the South, people. Okay, so there are these huge salt blocks they put out for deer to lick. If you drop one of those, it breaks everywhere. That's just because even though it's this big, strong crystalline structure, it's still brittle because it has these cleavage points where they just kind of, right where the bonds align, they can just chop in half and they can cleave, is what it's called. So that's something we'll talk about more. Okay, let's continue notes on maybe a separate page and we'll come back and we'll do covalent. Okay, let's stick only with ionic so far. So I'm gonna come back here. I'm gonna go back to the covalent properties in a second. Of these three properties, which of them are going to be indicative of an ionic solid? Electrolytic? Is that ionic? Yeah, okay, so that's gonna be ionic, okay? Volatile, we don't know what that is. We haven't learned about it yet. Not ionic. Probably soluble?
Yes.
Ionic, right? Okay, so looking at all four, or whatever, 6 of these examples, which of these examples are ionic? Which of these examples are ionic?
The first one.
Why, how do you know that?
Yes.
So it has a metal. Hey, you can just. Sorry. Okay, so we have sodium, which is a metal, and then a non-metal. Is this ionic? Yes or no?
No.
Why?
There are 2 non-metals.
2 non-metals. Is this ionic? Yes or no?
Yes.
Yes, because it's metal, non-metal. So you're thinking probably in your head, but if you had to consult something, what should you be consulting? The periodic table to see if they're on metal side or not. This one.
Yes.
Yes, metal, non-metal. Next.
No.
No. This next one.
No.
No. So, which ones are electrically conductive and probably soluble? Just the ones we wrote stuff about, right? So that one's ionic, that one's ionic, that one's ionic. So three of the 6 are ionic. So what do you think the other ones are? Covalent. Because it's non-metal, 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 non-metal. So that's pretty distinct differences between the two. Okay, let's go back and write covalent properties then. So this was practice for us. Covalent properties here. And they're on the, it's going to be on the right-hand flap where you wrote covalent. So on your little foldable that you've started for yourself, you have a Left flap, that's ionic, all stuff. This right flap of yours is now covalent. Sorry, it's probably hard to see with no lights on. But S says covalent, and I just have properties there, and you're just gonna write down some of the properties. You'll probably see they just contrast the ionic, so it's pretty easy. So, what do you know right now for types of atoms? Non-metal, non-metal. All right, which you might know is how do they form bonds? Anybody? No? Yeah.
Don't they share electrons?
Yes, so this one's like, here, take the electron, I don't want it anymore. I'll be the cation, you be the anion. That's what ionic does. This one's like, here, let's share. Let's just share the electrons. Nobody gets it. We're holding it between us, equally distanced apart. We're just sharing it. So right now, you should be able to tell me, are there any ions formed in covalent bonds? No, no ions, okay? So not ions. These things are just sharing. They're not taking or giving. They're just whatever they are. They're just sharing. Okay, their structure doesn't actually have like a true crystalline structure like I can say for that one. I'm just going to say they're molecules. And I'll draw an example. O, H, H. Ha! Water molecule. Okay. What do you think generally their physical state is? Our two examples so far that we've really mentioned, and I'm going to write over here, I know it says metallic, but I don't mean it. We've just mentioned water as a covalent compound, and we also mentioned carbon dioxide as a covalent compound. So what are some states of matter that those two represent? Liquid and gas. That is generally what they are. What's typically the water boiling point, or water's boiling? Sorry, not boiling point, melting point. Don't say the F one. Say the C one. Celsius. 0, right? Fairly low, right? So low melting point. And carbon dioxide's melting point is like negative 200 degrees Celsius or something like that. Negative 150. I have to look. Okay, I know this one's going to be dumb, but you're like, hey, is water soluble in water? No, water just mixes with water. Water itself is not soluble in its own self, because it is itself, so you can't be soluble in your own self. It's like a catch-22 here. Okay, carbon dioxide, though, is carbon dioxide soluble in water? When I say soluble, I mean that it ionizes. No, this is not an ion, right? But can you put carbon dioxide in water? Yes, because what is that found in? Soda, right? But what happens to the bubbles? They bubble out, right? They don't hang out in the water very well. So I'm going to say, generally, no. Not soluble in water. Do you think then, since that's the case, that they're not soluble in water, do you think they're electrically conductive? No. And I'm just going to say no ions, just to remind you that the ions are what's causing the electrical conductivity. So if you don't have ions, then you're not electrically conductive. All right, so far so good, guys? Some of it's probably familiar, I think. It says generally no, so no, generally no. So let's look down here again. Molecules, okay, low melting points. Oh, word volatile, this is for me. Add the term volatile to your list of properties, because volatile is something that we need to know that covalent compounds do. So who put deodorant on this morning?
Always.
Always. Okay, perfume. Little Axe. Little, I don't know what else. Cologne. Okay. So all of those things work, thank the Lord, by the mere fact that they are covalent. Okay? They work, they make you smell nice because your body temperature is kind of warm, right? So it makes those like substances that are solid when you put them on, right? When you put them on, or liquid when you put them on, it makes them vaporize really easily. So when you walk by, you smell nice. So that whole word, vaporizing easily, just means that it's volatile, or it has a tendency to vaporize. So example, deodorant. Okay, we have lots of other things like air fresheners. They do that. Hairspray, not hairspray. Well, whatever you spray in your hair, stuff like that makes you smell good. It's all working off of volatility. Yeah, and we got the rest of these kind of taken care of. So going back to that original 6 example list, I'll show you in a second. Okay, so this one, oops, let me go a different color. This one, and this one will have what kind of properties? Go, shout them out. Non-electrolytic, what else? No ions, low melting points, not soluble, liquid or gas, volatile, okay? So you should be able to identify a compound as ionic or covalent, and once you've recognized it as ionic or covalent, you're going to be like, oh, I know all the properties about it, and I know hot forms. Whew. Now we're going to learn about how it's named. Okay, you all have a card. Yes, at your desk? Okay, we're going to take about 5 minutes, not until more. And let me explain what you're doing. This little card is who you are. If you are a cation, what do you have to bond with? An anion. Cations and cations cannot get together. Anions and anions cannot get together. Those are the rules. So your job right now is to bond with as many classmates as you can, but as you bond with them, maybe on your note sheet, not on your foldable, I want you to write down the chemical formula. But what did we just go over for ion charges? What do you do with them to combine them? Crisscross, okay? I want you to crisscross the charges and write down the formula, okay? And when you're ready, the person next to you can start with, because you should have to hear that word, okay? Take a couple minutes. You don't have to? Yeah, write them down someplace. So here's an example if you need it. Just go to the compound, don't do this yet.
So we can make that chart.
You can make a chart if you want to, but all I want for sure, what I want for sure is the compound formula after you crisscross. That's the minimum I need.
Yeah, it'll make it.
Oh, so yeah, first thing you take that and put it in there. That's one. It just doesn't show up.
Alright, pay attention real fast. 5, 4, 3, 2, 1. Forgot to say, once you've made your pairing, so like Danielle and I have made Li2O1. I'm going to give her my oxygen, she's going to give me her lithium, and I'm going to go find somebody new. So you gotta get up. Okay? Switch them out, and you put on mine. And then
No, you don't take
so the
well, they go to like it's just
I'm a positive. Another fact. Look on the board right here. Look on the board right now. Positive ions are always written first. Cations are always written first. So that's my example. Sodium, then chlorine. Sodium, then chlorine. If your cation's written second, then you need to fix it. Cations come first. Lizzie, are you positive or negative? God, that's the one I started with.
Alright, I'll see what you're doing, Matt.
But you've been here like, oh.
No.
I keep forgetting that. I'll tell you about it. I know, that's why I should it is negative. Kathleen, are you All right, it doesn't matter how many you have. You're back in your seats in 5, 4, 3.
Those.
Uno.
Zero.
Okay, so I wanted to get you up and see that you could do that, because now that you know how to do that, the next part is going to be very easy. Somebody asked me, why are the charges, like the pluses and negatives, not coming with the numbers? It's because whenever you write out a chemical formula, like for example this one, calcium ion and nitrogen ion, or nitride, they get together to make what? Hey, what do they get together to make? So, no, tell me the formula. Spell it out for me. Ca. 3. Yeah, so I chose that one because that's what you did, right? So this is the formula. This is what kind of the structure looks like, and I want to indicate this to you because tell me the full charge of calcium 2, calcium 2, and calcium 2. What's all that added together? 6 plus charge, right? So that's 6 pluses that must be neutralized. Kathleen, with me? Must be neutralized by this. Well, what is this total? 6 negatives, right? 6 positives and 6 negatives do what? Make it 0. This is called electrically neutral. So the reason that we have to pull the numbers down is because I need 3 calcium 2 pluses and 2 nitrogen 3 minuses to cancel each other's charges out to make an electrically neutral ionic compound. That is very, very important. This is the multiple choice question. I already know that most of us are going to miss because we didn't write it down. Because that is the question that everybody misses on this test. Yeah.
So if we have the number 1, do we have to put it there? Or?
No. The 1 looks dumb, doesn't it? If you write it there, it just looks dumb. So I'm going to show you how to write it. So sodium and bromine. So sodium 1 plus and bromine 1 minus. You already know you only need one of each of those to neutralize them, right? Mm-hmm. So you're like, oh yeah, sodium, the Br drops its charge down, 1, and then the sodium drops its charge down here. But doesn't that just look dumb? 1 in the middle there. So if you write it for me as NaBr, it is understood there are 1s there. So what does that mean? How many sodiums are needed for every number of bromines? 1 and 1, 1-to-1 ratio. This is a 3-to-2 ratio. Okay, I did see one example that somebody did. It was beryllium, what was it? I'm going to say beryllium oxide. There's beryllium oxide.
I'll do that.
Yeah, I think some people had Be2O2. Yeah? Because it was Be2 plus, it was, sorry, those of you who didn't have this, it's like Be2 plus O2 minus crisscross down, and you're like, oh yeah, 2 and 2. But 2 and 2 are just like 1 and 1. They reduce. Don't say cancel, they reduce. Because if they cancel, it's like nothing's there, right? So this 2 and 2 needs to be reduced to BeO, 1 and 1, or BeO assumed ones. So that's actually something very important too. Reduce those things if they can be reduced. So 2 things we just learned. Electrically neutral is just the number of ions and the number of ions that are required to neutralize each other's charges. And that if you have a ratio that can be reduced, you need to reduce. Yes?
Do you want us to do that?
Mm-hmm. And it's called the empirical formula, EF empirical formula, and we're going to learn a lot about that in our next unit. Yeah.
So if you have Na2 and O1, and you just Na2 and then O.
Yeah, Na2O. Yeah. All right, we're going to practice with these now, but I need to talk a little bit more about polyatomics. Well, I haven't passed these out to you yet. Okay, so the polyatomic ions. Before I even talk about that, let's go to some easy examples first. Okay, and if I have a star on it, I want you to write it on your foldable. It's your choice still, but I'm just giving you some hints. If I have a star up there, write it in your foldable. So ionic naming. Ionic naming is practically what we just did.
Wait, what was that?
You're writing the instructions on how to do ionic naming. Write it on your foldable. On your ionic, inside class of ionic. And I'm going to pass out a couple things while you guys are listening. I'm trying a new, easier way of teaching this, so that's why I'm like kind of everywhere today. I'm trying to find a better way to speak our language. Ionic naming. And if you don't, guys in the front don't mind passing back papers. If there are extras, people just put them on the back. Huh? Not really. Probably just a working day thing. But we're good tomorrow. Okay, I'll give you one. Guys, focus on this on the board. I'm not going to leave it up here if you can't focus on what I've asked you to. So just pass back the papers, and then we'll talk about them in a second. Okay, so we actually kind of just practice writing formulas. We just crisscross charges. That's all we did. But sometimes we're going to have to find the charges or the other ions from a list right now. And that list is called the polyatomic ions. And that poly word means what again? That poly prefix? Many. So many ions together. So there are things more complex than we kind of just did. So previously we just got the symbol, we got the charge, and we crisscrossed. That's just straight from the PTOE. We know the charges based off the valence electrons they had. We crisscrossed them, and we made the atom electrically neutral by crisscrossing their charges and pulling the subscripts down there. Sometimes we're going to have a polyatomic ion. So on the sheet I just gave you, polyatomic ion list. What's the very first ion listed? Acetate. Acetate. You heard me say 8 there. So acetate is C2H3O2 1 minus. What do you think it's called? A polyatomic ion. It's got a lot of elements or atoms in that ion. Okay, I can take acetate and I can do the same thing I did earlier. So in this case, I did sodium 1 plus and chlorine 1 minus, and I crisscrossed them, mixed sodium chloride. I can do the same thing with this. Anytime you have, and you want to write this example down with me, okay? Anytime you have a polyatomic ion, it is in your best interest to protect the formula with parentheses. Leave the charge on the outside. So parentheses are going to be your friend on this. And the I'm going to just use sodium in this case. Sodium 1 plus ion. Just like earlier, you have your symbol with the charge, you have your polyatomic ion with its charge. You're still going to do the same thing of crisscrossing the charge. So crisscross that one down there, crisscross that one down there. What does that make? Sodium acetate. Sodium with a 1, but I'm not going to write the 1 because we know the 1 is there, but I don't write it. And then just fulfill this. C2H3O2. I'm going to keep my parentheses there so you can see the distinction between the two. So it's not a lot harder, it's just there's a lot of polyatomic ions that you need to get in your brain so that you don't always have to refer to this sheet, because that will take you probably 3 times longer to do a problem. Yeah.
Will you go back and do that again?
Yeah, let me do another one if you don't mind. So let's do the second polyatomic ion down, chlorate. Do you see chlorate on your sheet?
Yeah.
Does everybody have one of these sheets? No? No, not the back row? Okay. Pass that. Okay, so give me another metal. Give me a metal. Anybody? Yeah, one in, like, you know, the groups, or give me group 1 or group 2. Potassium ion. Okay, so potassium metal forms a 1+ charge. I'm going to put that with chlorate, and chlorate is ClO3 1-. Chlorate is just a bigger thing than simply an atom from the periodic table. So chlorate's 1+ comes down here when you crisscross it down, and the potassium 1 goes to the outside when you cross it down, and you just make potassium chlorate. Right. But what is the formula for that? This is the written out formula. ClO3. Because what are these imaginary subscripts here? 1 and 1. So those are just 1 and 1s. Yeah. You don't, but I'm going to ask you to for your own sake right now, because it actually is very helpful to see it as 2 names. First name potassium, last name chlorate. If you don't, you might be like some other people that I've known, and they're like, oh yeah, man, that's like potassium, chlorine, oxygen 3. No, it doesn't have 3 names. It's got 2 names. Potassium, first name, chlorate is second name. It helps you just see it better. That's all. All right, so let's do some more of these. And I'm going to ask you to reference your polyatomic ion list a lot. Before we move on, no, we'll talk about this. Polyatomic ion list. Okay, these are charges I'll come back to in a second. If I could possibly find my list. Okay, did I just pass out that big sheet of paper with some examples on it? Yep, calcium oxalate's the first one. I don't count well. I can do chemistry. I'm sorry. I'm really sorry. I just passed back handfuls of time. Okay. So I'm gonna go do the ones that I know you can do first, then we'll go back and take a couple more notes. Okay. So when you're writing the formula for calcium oxalate, the thing that you should first realize is that you know what calcium's charge is. What's calcium's charge? Look on the periodic table. You should not be looking at me. Periodic table. Why is it 2? It has 2 valence electrons and it loses them, right? It's because it's in the second group. It has 2 valence electrons. It loses those valence electrons. So it has a calcium 2+ charge. Okay, oxalate. Do you see that ending? The ending means it is not an element on the periodic table. It means it's on your what list? Polyatomic ion list. Tell me what oxalate is. Is it on there?
C2O4.
2-?
Yes.
Right, there's calcium, and then there's oxalate. Crisscross, what do you get?
CA.
Give me the whole thing and then we'll reduce. Ca, the 2 comes down there, parentheses, C2O4, close parentheses, 2, because that 2 from calcium 2+ came down. So Ca2, that 2 subscript came from oxalate's charge, parentheses C2O4, and parentheses, the second 2 came from calcium's charge. Yes, ma'am.
Since they're both 2s, can't you reduce it?
That's exactly what we're going to do. So we're going to reduce this 2 and this 2 down to 1 and 1. So Ca, parentheses, C2O4, and parentheses. 1 and 1 is indicated there by not writing anything down. And that, my friends, is calcium oxalate. Okay? Let me pick another one that I know you can do. Let's go to, I'll come back there and say it. Give me number 6. I want to indicate something else to you. So we just said 8s are not on the periodic table, but we've messed with ides quite a bit. All the things that you guys just did in your groupings were ides. They end in I. So that means it is from the PTOE. Okay, so tell me, lithium's charge? Why is it a 1?
There's only one valence.
Group 1, 1 valence electron, it loses that valence electron. It becomes a 1 plus charge. Carbide sounds like carbon. So carbon has what charge? This is one that you have to find the charge from on the periodic table. No, it's 1A through 8A, right? Ignore the whole teen part. Say again? Why is it 4? It's in the 4th group, so it has 4 valence electrons. It's either going to lose 4 or gain 4, but in this case, is it going to be losing 4 or gaining 4 because it has to be the anion here, right? So that's the cation, this has to be the anion, so it's a 4 minus charge. So it gained 4 to look like neon. Okay, crisscross, what's this big? I know it's lithium. I want you to spell it out for me, okay? Li4C1, but we know we don't have to write it. Okay, Li4C1. You're crisscrossing in your head, I see. This is good. This is good. Let's do number 7. I'm trying to do the easy ones first. 7, beryllium nitride. First thing you're doing is what? Beryllium is Be. Charge of beryllium. What? It's in group 2, so it happens to lose 2 valence electrons, so it makes Be 2 plus. Nitride sounds like nitrogen, so what charge will it attain? It has, okay, this is a good point. It has 5 valence electrons. Is it going to lose all 5? It's going to gain 3. It's one or the other. You lose all your valence electrons, or you gain enough to look like octet. Which is closer? Gaining 3, because it can go from nitrogen and go 3 places higher to look like neon, and that's going to make it gain 3 electrons, so overall have a 3 negative charge. Okay, so crisscross, what do you get? All right, who's feeling this so far? Okay, let's go back and do a polyatomic, and then we'll come back to some easy ones. Sodium bisulfite. So again, let me do aluminum permanganate. Aluminum permanganate. 8 ending is now periodic table, right? So we see the 8 endings, so you're going, oh, polyatomic ion list. So before we even touch that, tell me what aluminum is. Al, remember these are all ionic, because it's got a metal in it, so what's its charge? 3 what? 3 plus, because it's in the 3rd group, and it bounces back by losing 3 electrons because it has 3 valence electrons, so it's easier to lose 3. 3 plus charge. Where does permanganate come from? PTOE? Polyatomic ion. Polyatomic ion. Look on it. MnO4 charge. 1 minus. Okay, keep your parentheses there. Crisscross. Okay, Al1, I'm not going to write the 1, but we know it's there. 3. Al, MnO4, 3. So that pause tells me I know there's parentheses there. All right, so who feels good about looking at this written out formula and going, oh yeah, that's aluminum permanganate? Right now you do, right? But there's a lot of different polyatomics. You have got to start looking at them and making flashcards to get a hold of them, because there's a lot of them. So, and you will use them a lot. So I think naturally you'll start to kind of accidentally memorize some of them. But be intentional. So, next one, sodium bisulfite. Okay, so we've seen 3 endings now. What ending means I'm on the periodic table? I. So the other 2 mean what? You're not. Okay, you're a polyatomic ion. So sodium, can you write this in green here? Sodium is a what charge? 1 plus, because it's in group 1, loses 1 valence electron. Bisulfite. What? HSO3, 1 minus. Parentheses. Okay? What does that make when you put it together, crisscrossing? Okay. I'm going to tell you a trend on the polyatomic ion list. So look at Look at chlorate. Tell me chlorate. ClO3, 1 minus? Yeah? You see chlorate at the top? Okay. Chlorite. ClO2, 1 minus. What happened? You lose an oxygen. So an 8 has a specific number of oxygens. It is not the same number of oxygens in all 8s. So you'll have phosphate, sulfate, chlorate, bromate, iodate, nitrate, all these 8s. They have their own set of set number of oxygens. But if you memorize those, if you remember these, it is very easy to get to ite because all you do is drop an O. That's it. So pretty much I need you to know half of them because you can kind of figure out the other half by dropping an oxygen. There's more to this trend though, okay? So if I went hypochlorite, it's ClO1, 1 minus. So what does that prefix hypo mean? Okay, it does kind of mean -2 from chlorate, but what does hypo mean in general? Hypodermic needles. Under, right? Under the skin. Okay, it's my best example of hypo, unless you guys can figure another one. Okay, so hypo means below. Below. One more below. That's what I'm saying there. Below. Okay? And then the one above this, there is actually one above it. It's called perchlorate. And it's ClO4, 1 minus. So it went up 1 oxygen. So there is a trend, but if you know the 8s, you automatically know the ites. And if you see the prefix hypo, you're just like, oh, hypo, below, 1 more. Per, it's a little harder to memorize, but know the 8s for sure, and the other ones will come. So let's practice. Look at nitrate. What's nitrate? Look on your list. NO3, 1 minus, right? So then, but don't even look at nitrate. Look at nitrate and tell me what nitrite is. NO2, 1 minus. Okay. Look at phosphate. On your list, phosphate. PO4, 3 minus. So what's phosphite? PO3, 3 minus. Good. And let's go ahead and go back and finish up some more of these. I think we might not get the covalent today. That's okay. Oh, I went too far. Okay. So this is actually what we just talked about. Do I need to go over any of that again? That's how you figure out the charges. So group 1 gets a what charge? Quickly. +1. Next. +2. +3. Plus or minus 4. -3. -2. -1. It goes down because it's gaining electrons, electrons, electrons. Okay, so these are going to be a couple more things you want to write on your foldable. Those are charges of transition metals. So you'll notice we haven't actually used a single transition metal. The word transition means it has transitional charges. Yeah. In the nomenclature notes on the inside. So some of these have specific charges. So, oh, I forgot cadmium. Oh no, I have it down here. Sorry. Okay, so zinc, keep it with me. Zinc gets a 2+ charge. Always, never fails, okay? And why am I going over these? Because these don't follow anybody's rules, okay? D block doesn't have a set charge. D block doesn't have a set charge, so you have to know them or figure them out from the name. And I actually tell you them in the name. You just gotta know how to read the name to get them out. Yeah, question? Inside on the ionic.
Oh, ion.
It's all ions, ions, ions. These are all charges. Charges of T metals. Charges of T metals, transition metals. Alright, so zinc always gets a 2. And I think actually you guys knew this. You knew that because you knew this was 4s2, 3d10, and you knew it would lose the 4s electrons, making 2+ charge. So I kind of already knew that. Silver is weird. Silver is number 1, so I'll remember it. So I like silver way better than gold. But silver's number 1. I'm just trying to find goofy ways to explain this for you, okay? You always know it's going to have a 1+ charge. Tin is a little weird. And you'll notice that tin is not even in the transition metal group. It's over here by itself with lead. Yeah, it's on the staircase. So it's kind of in this area where you're like almost non-metals, but you're still metals. So tin and lead have their own charges. And that's the one I forgot. I don't have lead up here. So both of these form the same specific charges. Lead 2+ or lead 4+. And that's because, look at them. They're right on top of each other. So they basically have the same electron configuration, just one row apart. Cobalt forms a 2 or 3. Iron forms a 2 or 3. Cadmium always forms a 2. Copper forms a +1 or +2. So if you have that list, it helps you kind of figure out if you're in the right direction, but I'm going to show you how to figure it out from a formula as well. Sorry, today's a lecture day. We probably figured that out. Thumbs up when you have those down. Okay, so like I said, I'm going to somehow indicate to you the charge. Somehow. There are two ways I can do that. One way is called the stock system. That's what EXE is. That's not blocked here. This can be on the inside if you have room. Okay? You might have room. This is still regarding transition metals. So we kind of have this little special category about transition metals that have special rules on how to name them. So, first way to figure out the charge or how to indicate the charge of a transition metal. You don't have to write down all of these. These are just examples of transition metals, but you kind of just look at the periodic table in terms of the transition metal. No need to write that down. So if I say tin, Roman numeral 2, chloride, I'm telling you tin's charge. What's tin's charge? 2. So I'm going to say SN, charge. Charge of tin. Says it in the name, people. Right there. Okay? So this right here, when I wrote 10, Roman numeral 2, that means 10 2+. Here's a good example to include there. And then I'll finish it up here.
If it's in the parentheses, are they all going to be positive?
Yes. Good point. So transition metals are metals, and metals always form positive charges. They're always cations. Always. So they always form positive charges. Good point. Okay, so 10,2 chloride means 10,2+. What is chloride's charge? Look at your periodic table. Is chlorine going to gain or lose electrons? Chlorine is 1 away from noble gas, yeah? So it's going to gain. It's easy for chlorine to go up 1. So it gains 1 electron. And negatives are electrons. Or electrons are negatives. So that's how you know that. Okay, crisscross, what do you get? 2. There you go. That name, SNCl2, is called tin-2 chloride. So you would say it back to me. If I gave you a formula and I was like, tell me the name, write out the name for me, you would recognize first that that's a transition metal. And you go, oh, I have to tell her the transition metal charge. Because if you just say tin chloride, I'm like, tin what? Because tin has multiple charges. So I don't know if you're talking about tin-2 or tin-4. So that's why we have to talk about that and like be explicit that that is tin-2. And that 2 there would, kind of crisscross back to tin, so that's how you know it's tin-2 chloride. So tell me how to do this one. Lead is Pb, by the way. Pb4+, right? Because that's its charge. That's lead's charge. Sulfur with a -2 charge, because it is right here next to oxygen, and above oxygen, below oxygen, one of those, and then you go up 2 to look like argon. So crisscross those, what do you get? All right, and then I want you to tell me why that on Pb2S4. Tell me what's wrong with that right now. Right, PBS 2 because the 2 and the 4 can be further reduced to 1 and 2, right? Now, tell me, this is probably the hardest one. I'm sorry, I'll go down the classical system in a second. That's one of the hardest ones I will probably ever give you. Because when you look at that and you're like, oh, Miss Ellen needs to know the charge, right? What charge are you probably going to tell me when you look at that? 2. And that's a lie. It's not lead 2 sulfide. It's lead 4 sulfide still. So that one is a backtrack. You're like, okay, how did it become this way? Because basically, you always know that sulfide will have a 2 minus charge. So if you remember that and you're like, hey, where's the 2 that's supposed to go right there because it crisscrossed down? It should prompt you to go, oh, we already reduced. So I got to go back to that form to go, it's lead 4 sulfide. It's just kind of an extension that's kind of tricky. All right, so the first way of defining the charge of transition metals are the stock system. And this is actually how like my stock room is set up, exactly like this. If you were back in the day, a scientist back in the day, you didn't have a stock room, you didn't have this where you had the Roman numeral set up, you said the word differently to indicate the charge. So instead of saying instead of iron 2 or iron 3, you said ferrous or ferric. And I'll tell you how I remember. And actually, I think I kind of have it. No, I don't. Okay. So if the ending, and how do I know that's iron, by the way? I just said iron.
Fe.
Fe is iron, right? So why is iron Fe? It's because back in the day, they used to call iron ferric and ferrous. So that we have adopted the symbols from back in the day. All right, so if they say os on the end, I always think os is lower. Os is low. Os is low. It's the lower of the 2 charges that it possibly could have. You wrote down the 2 charges iron could have had. What were they?
2.
2?
2 and 3.
Or 3. So of the 2, which is the lower one,
2.
2. So os means the lower one. So in this case, it's iron 2. So for my first one here, Fe2. And then chloride is what? Cl minus 1. Crisscross, what do you get? And a FeCl2 is ferrous chloride, aka iron 2 chloride. They're the same thing, it's just one way of naming it is called ferrous chloride. And you'll only say that a couple times, so I'm not going to emphasize this a whole lot. If you're the ick ending, I always think you're the higher one. You're the ick ending. I don't know why that makes sense, but to me it does. So, os is low, ick is high. It's the higher one. So it's the higher charge. So it's iron 3 chloride. So iron FeCl3. They're right in order. Ferrous is the lower charge. Ferric is the higher charge. And so I've written them right next to where they belong. Okay, let's practice a couple more, including this, polyatomics, and normal stuff, periodic table stuff. And I'm going to save covalent for tomorrow. Covalent is so much easier. Covalent's like a tenth of this. So you guys will be happier. Okay, you will. Okay, so looking on the same list that I had earlier here for you. Let's go down to number 9. Chromium 3 oxide. What am I telling you? You should be able to rattle these off to me now. Chromium 3 oxide. Tell me the charge. So chromium with the 3 plus charge, Cr3 plus. Oxide. Iod ending means? PTOE. Looking straight on the PTOE. Tell me the charge of oxygen. 2 minus. Good. Crisscross, what do you get? So if you went backwards and you just saw the Cr2O3, would you remember to tell me it's chromium 3? But you have to force yourself to stop and go, okay, I have a metal. Oh my gosh, I have a transition metal. Oh my gosh, transition metals have specific charges, they have variable charges. I've got to tell them similar the charge. So then you go, oh, that 3 really came from chromium. So you're like, oh, chromium 3 oxide. So you just have to go baby steps. Stop. Is it ionic or covalent? It's ionic because it's got a metal. Then you go, oh, it's a transition metal. It's got to be. You have to tell me the charge. That's kind of your thought process. Give me another one. Let's do, nickel 3 thiosulfate. They sound like they're made up. They're not. Nickel 3 thiosulfate. So what is this telling you? Nickel's charge is 3. Thiosulfate. Where are you looking there? Polyatomic ion list, right? Thiosulfate. S2O 3 2 minus. Okay, crisscross, what do you get? Ni2 S2O3 parentheses 3. So I think looking at the name and finding the formula is easier. I don't know about you. But let's go backwards. Let's do a couple that are opposite. Naming the ions first. Here we go. This is on your paper. You have it? Yeah? All right, let's go backwards. Whenever you name an ion, when you're naming giving me the formula of something, all you do is specifically name first name and then name last name. The last name sometimes, thank you. The last name sometimes will end in "ide," or it will end in "ate" or in "ite." Those are your 3 endings. And those endings will vary based off if it's ending from an element on the periodic table or if it's ending as a polyatomic ion, right? So right now, you see this big thing and you see it's in parentheses. So what did I tell you parentheses usually indicates? It's on the polyatomic ion list. Parentheses, polys, right? So that one actually happens to be a cation. It's the only cation on the polyatomic ion list. What is it? It should be on there. Ammonium. Okay? Ammonium. All right, then you see that I don't have parentheses here, but you see there's a couple things remaining, right? Poly, many things remaining. So can you tell me the name of that? Sulfate. And I'm not going to say ion, just say sulfate. I get it's an ion. I'm knowledgeable enough to get there, okay? So that whole thing is called ammonium sulfate. That's it. But those are polyatomic ions. They're kind of hard. You got to look at that list over and over. And I want to remind you that this 2 does not belong to ammonium. Who did it really come from? The -2 that was sulfate's charge. Okay? So the subscripts don't just appear magically. They do have a reason for being there. So again, first thing you notice, oh, okay, easy one, right? What do you see? You just see Ca, right? Calcium. You just say its name. Its name is calcium. You see this thing in parentheses, so polyatomic, and you're looking at your polyatomic list and you see it's called phosphate. Calcium phosphate. Next one, this one looks pretty simple. It's just element 1 and element 2. No funny business. Right, so this right here would just, let me write calcium first. Calcium, and then if you just see something that's just one element, it's coming from the periodic table. And remember, ides are the endings indicating PTOE periodic table, so it's oxide, you're right. Basically, you're taking the name, like oxygen, and you're dropping the ending and adding ide instead. So oxygen becomes oxide. Give me another binary one that just has 2 elements, which is the next one. Number 5. So first name, last name, go. So bromine changes to bromide, right? Bromide. Do you see another one that's binary? Number 13. Hold on, what about number 11? You see element 1 and element 2, right? It has a 2 on it, but it doesn't mean it's ternary. It's just element, one type of element and another type of element. So name that one, number 11. Hold up, that's Ni. Nickel, nickel, L-E-E-L. Nickel, hold on. What kind of metal is this, guys? Transition metal, and you're like, oh man, I gotta tell you the charge. How do you tell me the charge? Parentheses, 2. Because that 2 really belongs to nickel, because you uncrisscross the charges. So that's just a reminder, if it's a transition metal, you have to tell me the charge. So nickel 2, and now I'll finish it up. chloride. Next one. Oh, tell me number 12. 12. I got you. It's the second group. Strontium. That was carbon. Carbide. Carbon goes to carbide because it's just simply from the periodic table. Next one. Yeah. Nope, because it's not a transition metal. Only the ones in D block plus the little lead and tin one are required to have a charge. Aluminum, I hear you. No, that you're thinking potassium. Phosphide, right. Phosphorus becomes phosphide. I know it doesn't sound right, but that's how it is. Phosphide. Do the next one, though. I'm liking that 13 and 14 are actually next to each other. Before I move on, though, why are there no subscripts indicated on ALP? They're reduced. Good. What were they? AL. Charge of aluminum. Look again.
4.
No. It's in group 3, right? It's got a 3 plus charge. Phosphorus was in group. It is still, not was. It is in group 5, but it gains 3 electrons, right? So it was Al3P3, but then we reduced it down to 1 and 1. All right, now name this one. First name, aluminum. And I'm going to put parentheses around this so you see that whole next thing is its last name. Right. And phosphate is from the polyatomic ion list. And it is a 3, good. So this was aluminum 3 plus previously, and this was phosphate with a 3 minus previously. And we crisscrossed the 3's, and it was 3 and 3, so we reduced it down to 1 and 1. So if I had instead given you the name aluminum phosphite, how would that formula change?
It would just be O3.
Right, instead of O4. So I just said, instead of giving you an 8 ending, I had given you aluminum phosphite. Then that would be AlPO3, not O4. Okay, here's what I want you to do for homework. The questions on the lecture notes, wait for me real fast. The questions on the lecture notes, do you have them right there in front of you? I don't know if in the actual list. I guess, okay, there are. These, do all the ones you can that are ionic, which should be the rest of the top. Should be the rest of the top. I'm not going to make you do all of these in the back, but soon we will get to some of them, okay? I'll adjust the homework on the website. So you're doing the rest of the ones on the top here. We'll do molecular stuff tomorrow.
If I printed it out, that's fine.
Put your box where it's right here on the way out.
I'll print it out, that's fine.
Yeah, I got you.
Where are you going?
You don't have to.
Figure I'm just staying there.
Reading guide, I took already. Good, never mind.
On this end then?
Yeah.